This is question 7 from paper 1-3 from the June 2020 exams from Cambridge International Education. In the description below this video, you'll find a link to an image of this question so you can try it before looking at my solution. This question asks us to show that this identity is true. Basically, they're asking us to show that the left side is equal to the right side, or the right side is equal to the left side. Don't be too afraid by this. It really just means equals, although it means equals in all occasions. So you might have something like, I don't know, x plus 6. This is a line, this is a function, y equals this. And then somebody else might come along and tell you, what happens when this is equal to 8? What happens when this is equal to 8? Well, when this is equal to 8, x is equal to 2. But that's not to say this is always equal to 8. This is its own thing. It's a function that looks like a line that looks something like this. It does not always equal 8. It does equal 8 sometimes, right here. That's what equals means. This just means it always equals it. So the only thing to say here would be x plus 6, x plus 6, really. It's identical. I draw the line on top of each other. But anyway, all that you need to take away from this is it's just like it equals. So just don't worry too much about it. Treat it just like it equals. So with that said, I want to try and get one side to look like the other. That's how I'm going to show it and show that this is true. I'll take the left-hand side. The left-hand side looks like I can do more with it. So I'm just going to play around with the left-hand side and until I get something that looks like this. So the first thing you can do on the left side is just add them together. We have two fractions, add them together. We often say cross multiply. I like to just think of it as getting the bottom row to be the same. So this one multiplied by this on the bottom row. So let's say this will equal to 1 plus cosine theta multiplied by 1 minus cosine theta. To get the same thing on the bottom row, I must have multiplied this by 1 minus cosine theta. So I must multiply the top by let's say 1 minus cosine theta. I'm running out of a little bit of room. And again, on this term here, I must have multiplied it by 1 plus cosine theta. Because I already multiplied the bottom row by it. So I must have multiplied the top. 1 plus cosine theta. Or, as most of you probably remember, cross multiply. That times that, this times this, and the bottom by the bottom. But anyway, that's what I did there. Let's clean this up as much as we can. Let's see, the top row, I can multiply all these out, but they both have tangent of theta in them, so let's just write that. Let's see, they have 1 plus another 1, well that's 2. They have minus cosine theta plus cosine theta, that's 0. So that's the top row. And the bottom row, yeah, I'll multiply this out because it helps. So let's say 1 times 1 is 1. Cosine times 1 and minus cosine times 1, they cancel. We get cosine theta minus cosine theta. That's because these are conjugates of each other. 1 plus something plus something, something minus something. We'll always cancel the middle terms. So we're then just left with minus cosine times plus cosine times minus cosine is minus cosine squared theta. Right, does that look like this? No, not yet. Although we do have a 2 appeared. Let's put the 2 there. Let me rub that bracket out. A 2 did appear. Maybe we're getting close, I'm not sure. Okay, so what do you do with this? A few things to remember. The most common things you're going to do in trigonometry. Always remember tan theta is equal to sine theta over cosine theta. Try replace that. Another one, also very common, is sine squared theta plus cosine squared theta equals 1. That's Pythagoras theorem. That's one of the things we define sine and cosine on. And this is what we define tan as. So these are very important things. With both of these, let's see what we would get. The top row will become 2 sine theta over cosine theta. And look at the bottom row, 1 minus cosine squared. If we take this over the equals, take it away from both sides, we get 1 minus cosine squared. So this this here is just sine squared. Because sine squared equals 1 minus cosine squared theta. Okay, we're getting somewhere now. Let's write this again. 2 times sine theta over, well, this is divided by cosine, and this is already divided. These are just on the same row. You can think of that if you would like, change this into over 1, turn it upside down. We get 1 times sine, and we get cosine squared times cosine theta times sine squared theta. Either way, whichever way you think about this, you will get this on the bottom row. And that is very nearly this. We just divide sine into both of them. There's 2 sines here, there's 1 sine here, this goes into this. And that's it, that's our final answer. 2 divided by sine theta cosine theta. I have them the wrong way around. The examiner will not mind about that. That is full marks. This is first part of question 7. Okay, so if you have any questions about that, put them in the comments below and I'll clarify anything. But otherwise, I'll move on to part B, and I think I have more than enough room here. Maybe I'll just rub this out, just in case. Right, so part B asks us to do, they use the word hence, and that's a very important word to keep an eye out for. Because if you did not know how to do this question, when you see the word hence, that means, okay, you're okay to stay going. You can just use this information. Hence means they've already given you. It means use what we've just given you. And they've just given us this. So you don't need to show it. You already know it. They told you it. And they tell us that this plus this is equal to 6 over tangent theta. But instead of writing this and plus this, why don't I just use this one here? 2 over sine theta cosine theta. That's what we need to solve. So let's try and solve that. This is just a trigonometric equation. Let's see. Let's multiply both sides by tan theta. Move it up here. Multiply both sides by this. Move it up here. So we get 2 times tan theta is equal to 6 times sine theta cosine theta. Again, we already know what tan is. We'll change that into sine and cosine. 2 sine theta over cosine theta is equal to 6 sine theta cosine theta. Sine and a sine cancel, or divide both sides by sine is a better way to think of that. Let's multiply both sides by this cosine. And while we're here, let's divide both sides by 6. So basically we get 2 over 6. Think of the 6 as moving down. And cosine moving up here. Oh, there's 2 of them now. There we go. We're pretty much at the end. We can just solve this. We would get cosine theta. Let's say we square root both sides, or we'll ask ourselves what squared would equal this. So this must equal plus or minus the square root of 1 over 3. 2 over 6 is the same as 1 over 3. And we put this into a calculator. We will get theta is equal to the inverse, we'll put this bit into a calculator. The inverse cosine of 1 over square root of 3. I'm sorry, plus or minus that. So we'll actually have 2 things to do here. So that means you need to put this into the calculator twice. The inverse cosine of 1 divided by square root of 3 will tell you that theta is equal to 54.7. Make sure you're in degrees. They ask you the question in degrees. Give them the answer in degrees. And also put it in the calculator again. The inverse cosine of 1 divided by minus square root, or minus 1 divided by square root of 3. That'll give you a different answer. That'll give you 125.3. So there are 2 answers. But let's also check that these are all of our answers. I like to draw out the picture of this part, whatever part we're getting the inverse of, because that's where calculators fail. They do not know how to do this too well. Calculators will only give you the first answer they find. So we draw cosine. It looks like this Yeah, it looks like this, but we only need to go in the world between 0. Here is 360. So here's 180. They are only interested in this world in here. So let me rub out the rest of it, because this doesn't exist. So there, one answer we found is when cosine theta is equal to plus 1 divided by square root of 3. And that's, well, you can put it in a calculator. I think it comes out around a half. But it's a plus number and it's less than 1. So it's somewhere here. There's only one answer to that, and that's the one we found. And the minus 1, it's less than 0, and it's bigger than minus 1. So it's somewhere in here. And again, there's only one answer to that question, and that's the one the calculator found. So often you might have it, like for example, if they ask this question between 0 and 360, it would actually get 2 answers here and 2 answers here. So the answers would be, well, I'm not sure. I guess this is what, 55 or so away from 180, so this will be 55 or so away this side, so 235, 234.7, I think. And this one here is 54, say 55 away from 0, so it's going to be 55 away from 360, which is, I guess, 305.3, I think. I don't know, don't quote me on them. So you have to be careful where all your answers are. In this case, the calculator found them all for us, because we were only interested in between 0 and 180. And that's where the calculator lives. The calculator loves between 0 and 180, except for tangent. Gets a little confused by tangent. And that's why we actually have 2 answers in this question, because tangent was in our original thing. Gives 2 answers between 0 and 180. Okay, I hope that answered this question for you. If you have any follow-up questions, which I'm sure you probably do, because I certainly didn't answer that perfectly, put them in the comments below and I'll do my best to get back to you. And apologies for the background noise, there's some work being done outside.